you. Welcome to your Waidsum academic maths, simple interest and compound interest. Okay, so what we have right now is simple interest. We've done simple interest already. We just want to quickly run through it. Okay, the interest you get that is charged just on a basic SSs, on a basic form. It's not like compounded. It's not like concurrent. It's just taken from the interest they charge from every money you borrow from a bank or every money you lend to someone else. Okay, the interest that accrue as a result of the money that you've lent to someone. And it has a very straightforward way of calculation. The simple interest is the principal times the time times the rate divided by 100. Rate is over 100. That's why we always divide by 100. Remember, rate is in percentage. Anything in percentage divided by 100. That's why you see the 100 in the formula. So the simple interest, the interest that you calculate or you get when you lend money, when you borrow money from the bank, the interest you get is calculated as, in my case, we used to write it SI, okay, as principal times rate times time divided by 100. So it's very simple and very straightforward. So what it means is that, for example, before we can calculate simple interest, we must know the rate with which the bank is going to charge you when you borrow money from them. When you borrow money from a bank, let's say you borrow £100 from a bank. Let's say you take £100 from a bank, then the bank will tell you the rate with which they will charge you the interest. They will give you a rate. This rate is in percentage. So this rate is over 100. This 10% means 10 over 100. So we're going to write here in the middle of this place, this arrow. Okay, the 100 is already written. We're going to put the 10 over 100 here. This is the 100. Yeah, you write 10 here. Then you multiply by the amount you borrowed. Let's say you borrowed how much? 100. You borrow 100, remember? Right? Or you borrow £100, right? So you borrow £100. So we say that 100 times the rate, which is 10, times the time. Okay, depending on the time. If the time is 1 year, you say times 1. If it's 2 years, you say times 2. Then over this 100. Then you get the simple interest. So simple interest is very easy. After getting the simple interest, to get the amount, the total amount that you go to pay, the total money you go to pay to the bank is called the amount. Remember, it's not the amount, the money you borrow that you pay back to the bank. Because when they give you with a rate, meaning you go to pay interest on top of it. So if you borrow £100 after 2 years, you are not returning to the bank 100. They're not for their Christmas. You're not returning. You're not returning £100 to the bank. You go to return maybe 110, 120, depending on the rate. The rate will help to evaluate or tell us how much interest you go to add to the principal. The money you borrow or you lend is called the principal. The money you borrow from the bank, I have explained this before. The money you borrow from the bank or you lend from the bank is called the principal, and then the interest, the rate is is in percentage. What they will use to calculate how much in simple interest you go to pay back to them. Then the time they will multiply by the time, the number of years. The time is always in years. In case you borrow for 6 months, you say 6 over 12. In case the money you borrow is for 6 months, you say 6 over 12. Because a year is 12 months. If you borrow, it becomes a fraction. If it's in months, it becomes fractional. Because the total number of months for 1 year is 12. So if you borrow for 5 months, you say 5 over 12. If you borrow for 8 months, you say 8 over 12. That will be the time. The time will no longer be counted as years, as 1 or 2 or 3. If it's in year, you say per annum. Per annum means 1 year. Okay, you say 1 times 1 when you are calculating. For t becomes 1 if you borrow for 1 year. If you borrow for 2 years, this t becomes 2. If you borrow for 3 years, this t becomes 3. But however, what if you did borrow for years? You just borrow for like 5 months. So this t, what will it becomes? T becomes 5 over 12. T becomes 5 over 12. So you write the 5 on top, you bring the 12 down. You bring the 12 down to the position of 100. So it becomes 100 times 12 at the borrow, at the denominator of this fractional formula. Is that okay? Can we move on? We've done this before. This is more or less like a revision. Let's take a look at an example, because in math, we cannot just be explaining. Yeah. in mathematics, we cannot just be explaining the concept, but we have to look at an example. Now, let's take a look at our first example for simple interest. We say a bank account offers a simple interest of 8% per annum, per year. Per year means per annum anyway. So the bank is going to give you a simple interest rate of 8% per year, right? A bank account offers simple interest of 8% per year. I put £250 into this bank account for 6 years. Find A, the amount of interest added over 6 years. B, the total amount in the bank account after 6 years. So there are two things we're going to look for. We're first of all going to determine the interest for 6 years. The first question, we're going to calculate the simple interest for 6 years. The second question is we're going to calculate the total amount of money that we would have accrued by saving our money in the bank for 6 years, by leaving £250 in the bank for 6 years. So the total money that it will amount to in your bank account. Now here it's how it goes. Remember we say here you have to bring out your parameters. The things that have been given to you, write them out. Here the money you've kept in the bank account is £250. So the principal is £250, okay? Our principal is £250, this one. That's the money is either the money you borrow in case of borrowing or the money you saved in case of savings. For this question, this is a savings question. We're saving the money in the bank account. So the money we're saving, or the principal, is £250 because that's the amount of money you're saving. Now the bank is giving you a rate for interest about 8%. The bank is giving us a rate for interest. The bank is giving us a rate for interest for about 8%, right? Since they're giving us 8%, that's what we're going to use for our R. Our rate will be 8. And then they say for 6 years, your time is 6 years. You're living it for 6 years. So our T is 6. So now going back to this formula, I or SI, in some cases we write simple interest as SI. Some cases we just write the interest as I. So we say is equal to principal times time times rate, or times rate times time. It doesn't matter which order, over 100. Okay, when you do this, the principal is 250. That's the money you save in your bank account. The money you save in your bank account is 250, right? So the rate is 8, and then the time is 6, right? So divide by 100. So when you do this, like you can cancel, if you don't have a calculator, you can do it manually, right? You can say 2, this 0 cancel one of this 0, right? 2 can go into 8, you get 4, 2 go here 5, right? The 5 at the denominator remaining, divide by 25. 5 into 5, 1, 5 into 25, 5. So you have 5 times 4 times 6. So that will give us 120, right? That will give us 120. So this is what we get as the interest, right? 120. So this is for the first question. For the big question, you say, what is the total amount after 6 years? The total amount after 6 years, total amount of money that you have accrued into your bank account after 6 years. Assuming you put £250 for 6 years in your account. So what do? Amount is always the principal plus the interest. Amount is the principal plus interest. The principal is 250 and the interest is 120. So you add them together, you get the total money in the bank account. The total money in the bank account will be £370. Is that okay? Do we understand that?
Yes.
Okay. Now let's move on. Now we are in compound interest. What is compound interest? Compound interest is kind of a little bit naughty. Kind of a little bit, not naughty as in naughtiness, but naughty as in it takes more money away from you. In case you borrow money from the bank, you're going to pay more money than using simple interest for calculation. Yeah, that's why I say kind of a little bit naughty, that they're going to take more money away from you if they use compound interest to calculate your amount of money. You know why? In compound interest, they'll calculate the interest yearly. The interest they calculate this year, they'll add it to the principal for the next year. So the principal for this year, they will use it to calculate interest, right? They'll get a certain amount of interest. They will add it to join the principal for the next year. So your next year principal will no longer be 250 pounds. Your next year principal will be around maybe 260, 270, depending on the interest that you calculated for your first year. So it's compounded. The third year, the interest again, you add it to the 217, to make a bigger principal. So every time the principal they are investing to collect your interest is getting bigger and bigger. So at the end of the day, you're going to pay more money. What I mean is compound. It's compounded. Compound is like multiple things running together, put together, right? Not a single case. Like we just use in simple interest, we just use a single formula to calculate, right? In simple interest, we just wrote a straight out formula to calculate the interest. In compound interest, this is what they will do. In compound interest, they will take the principal times the rate, 8, times, they will use the first year, they will call it 1 year first. They will use 1. So you say 250 times R times over 100, right? You get some rate. Can we use a calculator? Can we find that quickly? Let's see, what do you get? If you say, let's say we want to turn this to compound interest now, for example, 250 pounds times 8, which is the rate, times 8, right, which is times 1. Anything times 1 is the same thing, right? Then divide by 100. So when we divide by 100, we get 20, right? 20 is the interest. We'll get 20. They will not use the whole 6 years. They'll be using one year. First year, they will just call it 1. They will get $20, 20 pounds, sorry. They'll get 20 pounds. Your second year principal, they will take this 20, they will add to 250. They will add to your principal. It becomes 270. Your second year will now be 270 pounds. So 270 times 8, which is the rate, right? Divide by 100. You get 21.6 as your second year interest. This second year interest, they will add it to second year principal to form a third year principal. So they will add it to 270, which was your second year principal, to form a new principal for third year. You see, they are compounding it. The money is compounding. Are you with me?
Yes.
So, your third year principal is now 291.6. Now that 291.6 times the rate, which is 8%, 291.6 times the rate, which is 8%, times 1. It's every year they're seeing it as 1. Every year is 1 for compound interest. Okay? Then you get divide by 100 in order to get our divide by 100. You get 23.3. Now we get 23.3. Now this 23.3, they will add it to your fourth year principal, which is your third year principal, to get the fourth year principal. So they will add it, it will be 291.6 plus this one. You get 300. You get 314.9 as your fourth year principal. So if you want to do fourth year, you take this 314.9 times 8, which is the rate, 8%, which means 8 divided by 100, right? Divide by 100. You get 25. This is the interest for fourth year. To get the fifth year, you have to add this interest for fourth year. You have to add it to your last principal. The principal for fourth year, which is 304 point something. So it keeps compounding. Now let's go, but there is an easy way of doing it. This is a manual way. There's an easy way by just using a formula. By using a formula, we can sort it out. Now, by using a formula, the way to do it is quite easy. What we just have to do when we are using formula is to look at what I'm about to show you. Are you with me?
That's how we choose.
Yes.
Okay, just look at what I'm about to show you.
Actually, start.
Can you see?
You see?
Yes.
Okay.
Yes.
Okay. Okay. So for compound interest,
For compound interest,
we have easy way. Instead of like doing first year, we do first year principal like the one I was explaining manually just now. We have a formula. The formula is amount is equal to the principal bracket 1 plus the rate raised to power n. N is the number of years. This is the formula. This is the formula. This is the formula. So for compound interest, you just say the amount is equal, it's just like annuity. Amount is equals to the principal P plus 1 plus R. R is the rate to the power of n. N is the number of years. So imagine that 250 pounds you are investing and the bank is paying you 250 pounds, right? You are investing, this is your principal. And the bank is paying you with a rate R of 8%. Just like in case of simple interest, the one we had just now. Then the number of years, just now we're using T, but we can use N in compound interest to represent the number of years. Or you can still call it T. Okay, so okay. So we said the number of years is 6. Right? The number of years is 6. Now let's find the amount after 6 years. Let's take a look at the amount after 6 years. So amount will be equal to the principal, which is 250 into 1 plus the rate. Our rate is 8%. And this 8% in this case is same as 8 over 100. But I can easily convert it to decimal. So I can change it to if you change to decimal, it will be 0.08. Am I right?
Yes. 0.08. Yes.
Okay. So let's put the 0.08 here. Then raised to power 6, which is the number of years. Are you with me? So we say compound interest will be equal to, or the amount is equal to the 250 into 1 plus 0.8 will be 1.08 to the power of 6. Right? So this is what we get. So but we have to continue. Can someone do 1.08 to the power of 6? Can you tell me the value?
Okay, what?
1.08 to the power of 6. What's the value?
Wait,
Yeah, anyone with a calculator, can you do that for us? 1.08 to the power of 6. Hurry up. 1.08 to the power of 6.
to the power of 6.
You get 1.8.
1 point what?
1 point what?
1.58.
You sure?
You sure?
Yes.
You did this? Can you see the camera?
Huh?
Huh?
Yeah. Show. Let me see.
Sure. Let me see.
So 1.08
1.08
to the power of 6.
to the power of 6.
You get
You get
1.5866.
1.5866.
Yes. 1.5868.
66.
66.
Okay. Whatever.
Okay. Whatever.
Okay, 2. Different created it.
Then multiply by
Then
250.
multiply by 250.
Whatever you got, multiply by
Whatever you got,
250.
multiply by 250.
Okay. If multiplied by 2, you get 3.173.
You get what?
You get what?
3.173.
3 point what?
3.973.
Yes, 3.17374.
I can say 3 points.
It's 3 points.
250 multiplied by 1.5. You are saying 3
You are
points.
saying 3 points.
Multiply by.
Are you alright?
Are you alright?
3. Multiply by 1.
250 multiplied by 1.5866.
1.5866.
Point.
396.
396.65.
396 point what?
96 by what?
65.
Okay, this is the amount.
This is the amount.
Now you can see
Now
the
you can
interest.
see the interest.
What's the interest? Amount will be.
Amount will be.
Sorry. Compound interest
Compound interest
equals to amount minus
equals to
principal.
amount minus principal.
Right? So the
Right?
compound interest
So
will
the
be
compound interest will be
396.65
396.65
minus
minus
250.
250
Minus 250.
minus 250.
396.65
396.65
minus 250.
minus 250.
What do you get?
What do you get?
146.65.
146.65.
146.65.
That's what you got. That's the interest.
That's the interest.
You can see this interest is
You
bigger
can
than
see this
the
interest is bigger
simple
than
interest we
simple
calculated.
interest we calculated.
Simple interest we calculated was 120.
was 120.
120 pounds.
120 pounds.
But when we calculated the compound
When we
interest,
calculated the compound interest,
we got what?
we got what?
146.65.
146.65.
Right?
Right?
Yes.
So that's why whenever they use compound interest, meaning you're going to pay more money.
you're going to pay more money.
So it's very easy to use this formula to do compound interest. Super easy to use this formula. And the formula is amount equal to the principal
the principal
bracket
bracket
1 plus rate
1 plus rate,
close the bracket, raised to power n.
close the bracket, raised to power n.
So you just put the principal
You just put the
250
principal 250
into 1 plus
into
that
1 plus
rate
that rate
is, we convert it to
we
decimal.
convert it to decimal.
It was 8%.
It was 8%.
When we convert to decimal,
When we convert to decimal,
it becomes 0.08
0.08
raised to power 6.
raised to power 6.
Then
Then
you add that 0.08 plus 1 inside the bracket. You add what is inside the bracket first, and then you get 1.08. Then you raise it to power 6. Just type 1.08 to the power of 6 in your calculator. You get 1.5866. Then you multiply it by the 250. You get 396.65. So that's how we calculate the amount. Now to get the interest, remember this is not the interest. To get the interest, the compound interest, you say compound interest is equal to the amount that you've just calculated minus the principal, the money you invested. What remains becomes your compound interest. Are you with me?
Are you with me?
Okay, now let's go back to our. Okay, so this is the formula that for the amount. You see they wrote R over 100, right? Remember it was 8 over 100. I changed it to decimal, it becomes 0.08, right? From here. It's still, okay, this is the one in the formula I wrote. This is the R which I changed to decimal. 8 over 100, which becomes 0.08. This is n to the power of 6. So this is the formula we use for calculating the compound interest. Is that okay? This is the formula we use for calculating compound interest. It makes life much easier. Now let's take a look at an example. Let's take a look at an example from our slides here. Now it's a Jasmina invested £1,200 in a savings account which pays a compound interest at a rate of 2% per annum for 7 years. Oh, this rate is very small. So this is good. Okay, they give her, but the interest they're going to give her will be small because the rate is small. Okay, so now to find this, because they're going to use compound interest, we can easily use the formula we just mentioned. Other than that, you can see the way they got 1 to the power of 7. It's like you, first of all, it's like you are changing this one, multiplying it several times. If you don't know how to say, like the one we did just now when we said 1.08 to the power of 6. If you don't know how to do that, you can just say 1.08 times 1.08 times 1.08 times 1 in 6 places. Then you still get the answer. Okay? You say 1.08 to the power of 6. You remember in this 6 is 1.08 times 1.08 times 1.08 in 6 places. You have to do the multiplication in 6 places. 1.08 times 1.08. Are you with me? Now for this case, our rate is 2%. Remember 2%, if you bring 2 here in this formula, it will be 2 over 100. 2 divided by 100 will be 0.02. 2 divided by 100 will be what? 0.02. So 0.02 plus 1 will be 1.02. 1 plus 0.02, you know the rate is 0.02. If you say plus 1, you will get what? If you say plus 1, I want it to be alive. If you say plus 1, you get 1.02. So that's how we got this 1.02. I know you'll be confused here. How did they arrive at 1.02? Where is this 1.02 coming from? This 1.02 is coming from this parenthesis inside the bracket, this thing, 1 plus r over 100. It's coming from here. Okay, that 1.02 is coming from this 1 plus r over 100. R is the rate. rate in this case is 2%. 2% means 2 divided by 100. If you change to decimal, it becomes 0.02. 0.02 plus 1 will become 1.02. 1.02. So that's how we got. So we say raised to power 7 because this example is 7 years. The money is invested for 7 years. Okay, you say over raised to the power of 7. So that's how we obtain this. If you don't know how to press calculator to get 1.02 to the power of 7, if you don't know how to do that, what you can do, you do indices. You do what we call indices by saying 1.02 times 1.02 times 1.02 times in 7 places. Make sure they're up to 7 places. 1, 2, 3, 4, 5, 6, 7. So they are in 7 places. You multiply all of them, you still get the same answer by saying 1.02 to the power of 7. Is that okay? So when you do that, whatever you get, when you raise to the power of 7, you multiply by 1,200, which is the principal, 1,200 pounds. Then you will get 1,378. This is the amount. Remember, this is not the compound interest. This is the amount. This is always a amount. So the amount, if you want the compound interest, you say this amount minus the principal minus 1,200. You get 178.42 as your interest. Are you with me? Now look
Yes.
look at the explanation. Like I said, 1,200. You open bracket 1 plus 2 over 100. Remember, I just made it easier for you by making it in decimal. 2 over 100 is just 0.02. Okay, to the power of 7. Then when you do that, can you see the screen? When you do that, you will get this 1,378 as the amount. This is the amount of money that you're going to get after investing 1,200 for 7 years with a rate of 2% compound interest. Are you with me?
Yes.
Okay.
Yes.
Now, if there is depreciation,
Yes.
the one we've just studied is for appreciation. There are things that appreciate in life. There are things that appreciate in life. There are things that depreciate in life. For example, if you buy land, if you have a piece of land, it appreciates. If you buy land like 20 years ago in Kuala Lumpur for let's say maybe 1,000 pounds, or okay, let's say 10,000 pounds. You buy a piece of land in Kuala Lumpur for 10,000 pounds 20 years ago. As I speak to you, that money is more than 100,000 pounds now. So over the years, it appreciates. Yeah, in fact, that money is more than 500,000 pounds now. So there are things that appreciate. The things that appreciate, they are the things that we use plus here. We say 1 plus. Like you save money in the bank, it appreciates. If you save money, it appreciates, right? Are you with me?
Yes.
If you save money in the bank, it will appreciate if you save the money. Okay, if you keep a piece of land for over some years, it appreciates for you. If you build a house, over some years, it appreciates for you. So for the things that appreciate, when we are using this compound interest formula, the annuity part, this annuity part, the 1 plus the rate, percentage rate, we will use plus. We use plus, 1 plus. But there are things in life that depreciate. It's not everything that appreciates. There are things when you buy them after some years, they depreciate. For example, your laptop right now. If you buy a laptop now, maybe you spend let's say about 1,000 pounds or $1,000, for example, to buy a MacBook. 7 years later, that MacBook cannot worth 1,000 pounds. Am I right? It's going to depreciate in
Yes.
value. It's going to depreciate in value. So probably you may sell it 300 pounds or even less, or 250 pounds after some years, after using it for
Yes.
like 7 years. So for this type of things, like buying a car, if you buy a car now, right now, let's say if you buy a car for 10,000 pounds right now, 10,000 pounds, in 7 years' time, you may probably sell it for like, let's say, 3,000 or 4,000 pounds. These things, they depreciate in value. They've served you. They've actually worked for their value, but they depreciate eventually. These things, in the annuity part, we don't put plus. We don't say 1 plus the rate, a percentage rate. We say 1 minus the rate, the percentage rate. Now, look at it, for example. Let's take a look at it in this manner. Those things that depreciate, we don't use plus. Those things that appreciate, like population appreciate, we use compound interest to calculate population of a town or a village or a city because it keep appreciating, population keep appreciating. So we use this for the initial population is what we call the P, the principal. That's the initial population. But we don't use the one with the minus because population appreciates. We use this part that use a plus. But whatever depreciate, like your value, like your cars, your laptops, some of your properties that depreciate, we use minus to calculate them. We use minus here, okay? Don't worry, as you do more studies, you find the practical use for this. Now let's take a look at an example of things that depreciate where we don't have to use a plus. We don't have to use a plus, we have to use minus. One of you say, Messi buys a car for £20,000. Messi buys a car for £20,000. Each year, its value depreciates by 15%. You see, the value of the car depreciates each year by 15%. Find the value of the car after 3 full years. So what are you going to do? You're going to say, first of all, you convert the 50% to decimal, which is 50 over 100, which is 0.15. 50 over 100 is 0.15 in decimal. So you now say 1 minus 0.15, you get 0.85. So you're going to raise to power 1 0.85 to the power of 3 because it's 3 years. Whatever you get, you multiply by the amount he bought the car. It's like you're still using this formula. The amount, look, this amount, this 20,000 I'm signaling, this one that I'm showing you here, is this P, Now, this 0.85 is the entire thing inside the bracket, is the entire thing inside this bracket. Is the whole of this thing inside the bracket. How? This one is this one. You see, they say 1 minus 0.15. The 0.15 is the 15 divided by 100, which is 0.15 in decimal. So 1 minus 0.15 is the whole thing inside this bracket. This thing inside the bracket is this one, 1 minus 0.15. 1 minus 0.15, you get 0.85, right? Meaning what we have here now is 0.85. So 0.85 to the power of n, because you've evaluated what is inside the bracket. Since you've evaluated what is here, you raise it to power n. So 1 minus 0.15, which is 0.85, meaning this 0.85 raised it to the power of n. Power n is 3 years, because they say find the value after 3 full years. So n is 3. So you say 0.85 to the power of n, to the power of 3. So, which is this whole thing. This 0.85 is the whole of this one. Then to the power of 3, 3 is the number of years. So the whole of this thing, this bracket and the number of years, is this 0.85 to the power of 3. Multiply by 20,000, which is the principal. Multiply by 20,000, which is the principal. So when you are doing compound interest, what's the first thing you do? Is inside the bracket. This is where you evaluate first. You first of all convert this percentage into decimal by saying whatever they gave you divide by 100. If it's 15%, you divide by 100, you get 0.15. So you now say 1 minus 0.15. You not, after you do the conversion to decimal, you say 1 minus whatever is here. If it's a depreciation, something that depreciates. If it's something that appreciates, like saving money in the bank or like bank borrowing you money, it's going to appreciate for the bank after they borrow you money, because the money will stay with you, use it to do business, they will collect interest. So you got to use plus. But if it's something that depreciates, like you buy a car, you buy a laptop, you buy anything, you buy a wristwatch, you buy anything valuable to you that eventually depreciates, things that depreciate, then we're going to use minus here. So 1 minus 50% will get 1 minus 50%, 50% is 0.15, so 1 minus 0.15 will get 0.85. So when you raise to this n is 3, number of years. So it becomes 0.85 to the power of 3. You evaluate that in a calculator, and then you multiply by your 2000, which is your P. The last thing you do is to multiply whatever you have done here. The answer you get when you raise this one to power 3, you now multiply with the principal, which is 20,000, and then that will give you 12,282 pounds and 50 pence. So this is a car he bought for $20,000 pounds. This is a car he bought for 20,000 pounds just 3 years ago. Now, after 3 years, if he wants to sell it, he can only get 12,282,50 pence. So this is how much he can get after 3 years, meaning the car is depreciating. So if he waits longer, the value will go down more, because this will be calculated, 50% will be calculated yearly like this. It will keep going down, and at the end of the day, you will not have enough. You will not sell it for enough a lot of money. Is that okay? So look at it. Put it in the formula. This is the formula for things that depreciate. So if you put it in the formula, you put 20,000. Okay, there's an omission of 10 here by mistake. There's an omission of 10. So this is 20,000 into 1 minus 50 over 100, then raised to power 3. If you evaluate this in a calculator, you're going to get 12,282.50. Is that okay?
Yes.
So that's compound interest. Are we ready to try some question now?
Yes. Okay. Yeah.
I think next topic will be next time, right? I think this one is. Do you want me to continue?
No, let's do the questions.
Yeah. Let's do some questions.